Hello everyone. In the earlier episodes, we have discussed that kinetic theory of a gas is based on the molecular picture of matter. Any matter, either it is solid, liquid, or gas, the molecules of a particle or substance, they either oscillate about its mean position or they move from one point to another, and they move randomly in different directions in particular case of gas. So those molecules or particles which are randomly moving with different velocities sometimes interact with another molecule and come close enough to experience force of attraction or force of interaction, and thus their velocities changes. These interactions are called collisions. The molecules collide continuously against each other or with the walls and change their velocities. And also we have considered that the collisions are elastic, they do not lose energy in any form. So before collisions they move certain distances, and after that distance traveled in time, then they collide with each other. We have assumed that if a particle move distance L1 before collision, then again this move distance L2 before second collision, and L3 before third collision, then similarly if the same particle collide m times, then the distance traveled before or between each collision is Lm. So now we have m number of collisions, then the mean free path, that is the free path is what? The distance traveled by the molecules before collision. So if we take the mean of those free paths, then we called it as mean free path. Mean free path is what? Let us understand what is free path. Free path is the distance traveled by the molecule between each collisions. And if we take the mean of all the distance traveled during between collisions, then it will be termed as mean free path. So sum of the lengths divided by number of collisions give us mean free path length. Mean free path length. As we know that the free path length measure is impossible. To measure free path length is impossible because the particles are very small. Therefore, we have to find out another expression to measure mean free path length or the path length before each collision with the help of the dimensions of the container. Here we have considered a cylinder of radius d, and we also considered that the diameter of the molecule is d. If the velocity of the particle or molecule is v, we have considered average speed of a single molecule. Therefore, I am putting this bracket here. If the velocity of the molecule is v, then the distance traveled by the molecule in time delta t is equal to what? Distance traveled in time delta t is equal to product of average of velocity or speed multiplied by delta t time. Okay, so we can say that in time delta t with velocity v, molecule move distance v delta t. Also, I want to show that a molecule with diameter d collide with another molecule if their center distance is equal to the diameter of a molecule. Okay, again I am saying a molecule of diameter d will collide with every other molecule if their centers is equal to the diameter of a molecule. So one molecule will collide each molecule if their centers distance or separation is d. Therefore, I am using a cylinder of diameter d. Obviously, you will confuse if the diameter of a large cylinder is a radius of a large cylinder is d and the diameter of a molecule is d, then how is it possible, isn't it? So to keep analogy with this concept, I am using a cylinder of radius d. Is it clear now? Is there any doubt? Let us consider the three molecules of a gas. This is the first, this is second. These two are at the periphery of the cylinder I have drawn. So this is the third molecule which is randomly moving. During its motion, if their centers are at separation d, then 3 will collide with 2 as well as third molecule will collide with the first molecule also. And let the distance traveled by the molecule, third molecule at time delta t is average velocity multiplied by delta t. So in time delta t, the molecule will sweeps a volume of pi d square, which is the area of this cylinder, pi d square multiplied by distance average velocity v delta t. So the expression of the volume of the cylinder pi d square delta v delta t is equal to the volume swept by the molecule. So if n is the number density, if n is the number density, if n is the number density, that is number of molecules per unit volume, number of molecules per unit volume, then the molecule suffers, then the molecule suffers n pi d square v delta t number of collisions in time delta t. If n is the number density, that is the number of molecules per unit volume, then in time delta t molecules suffer n pi d square v delta t number of collisions. Rate of collision is equal to number of collisions per unit time, that is delta t. So rate of collision will be n pi d square multiplied by average velocity. So the time between, from this expression we can say that the time between the two successive collision, the time between the two successive collision tau is equal to 1 divided by n pi d squared multiplied by average velocity squared multiplied by, so this is the time between two successive collisions, that means time between two consecutive collisions. From this expression we can find out the average distance between two successive collisions or two consecutive collisions. Therefore the average distance between two successive collisions is called mean free path, which I am showing here. The expression is this. We are finding values with respective to the dimension of the molecule and its speed. So the average distance between two successive collision is called mean free path, and this L is now the product of average velocity squared to the time between two successive collision. So we will put value of tau here. It is L is equal to 1 by n pi d square, n pi d square. So this is the expression for mean free path. This is the expression for mean free path. So mean free path is equal to 1 reciprocal of number density pi d square. What is d? D is the diameter of the molecule. D is the diameter of the molecule. In this case or derivation, we have considered that only one particle is moving and other molecules are at rest. But actually all molecules are moving at different speeds, and the collision rate is determined by their relative velocities, or comparing velocities of each molecules. So taken into account the relative velocity of the molecule, so the most precise expression for mean free path will be 1 by root 2 n pi d square. This expression is for the particle are at rest, only one particle is moving, and this is the expression in which we have taken into account the relative velocities of the molecule in motion.